So we want to figure out the brightness of this star. So let's draw a star here somewhere.
Let's draw a star. It's a nice star.
Mm-hmm.
I want to figure out, you mentioned the brightness, so let me just write brightness.
Yep, and we know that the brightness is going to depend on the energy per second that the star is creating, emitting into space, right? So the more energy per second that the star emits into space, the brighter it will be, right? But it also depends on the distance, right? Because stars that are further away are not going to be as bright in our eyeballs as stars that are right next to us. So we know those two things, and we got to figure out what the equation is relating brightness to those things.
So we mentioned that it depends on the energy per second. There's actually a fancy word for that, and that is luminosity. So I'll just write that up here.
Not lumosity, which is the site you can go for quizzes and things, which has given us absolutely no money.
Nope, it's luminosity. And we also mentioned that it depends on the distance we are from the star. So the star is emitting radiation. So if we can imagine the little star that we have here, it's emitting all this energy in all different directions. And we want to figure out how much of this energy per second, to figure out its brightness, we want to see how much of this energy per second it is giving out at some position out here. So it's filling out all this circle. In space, since it's 3D, it would be a sphere. And we can pretend we are out here. So this is Earth. This is us. That's a symbol for Earth in astronomy. So the distance from the star to the Earth, since we're in 3D and it's a sphere, it's going to be the equation for the surface of a sphere, which is 4 pi r squared. Now, in astronomy, we do not use r for the radius, because this r would actually be the distance from the star to us here on Earth. Since that's a distance and not a radius in astronomy, instead of using r, we always end up using d. So d for distance. And that, again, will be this, which ends up being, for example, the radius of that sphere.
Here's an important thing to mention, which is that this brightness is the only thing that determines the size of the stars on the sky.
Right.
So they look bigger, but are they bigger in reality?
They are not.
No, they're all very, very tiny. In fact,
they're so far away, they appear to be very, very tiny.
There's only like a handful of telescopes in the world that have all this sophisticated interferometry stuff to try to measure the sizes of the stars. So at the end of the day, it's the brightness that is how big it appears. But this might not necessarily have anything to do with how big or how small the star is, right? Because the luminosity is whatever it is, and this distance that we are to it is whatever it is. So this has very little to do, if anything, with the actual physical size of that star. So all right, so we got this. Now what we want to do is we want to put this into the code.
Right. And see if we can make a more realistic picture of the night sky with using our code. So let's test that out.